Okay, let's look at this half-life example. So in this one, and half-life means like in this case, it's 16. The half-life 16 hours, and you start out with 100 grams. So 16 hours later, there's only going to be 50 grams, and then 16 hours after that, there's only going to be 25 grams. So it tells you as something decays, how long it takes until only half of whatever there was there before is left. All right. Okay. So anyway, the question is, when's there only going to be 20 grams present? If it happened to be 25, that'd be a lot easier to answer. But since it's 20, we have to do a little bit of work for it. So I'm going to do it two slightly different but heavily related ways. Um, so first, I'll call a function for how much is left at any time f of t. Um, it's a function of time. And I know that, so this is the amount left. And I know that when I plug in 0, I get 100 grams. So you have a couple options here. Some students like to think of it like this. F of t equals 100. And then you know that you're cutting it in half every so often. So it's 1/2. And then a lot of students like to just say to the t to kind of keep the equation looking simple. But if you do this, you have to realize that t is not hours here. T, in this case, like when t is 1, that means 16 hours have gone by because that's when you cut it in half. So in this case, t equals the number of 16-hour increments, or really the number of half-lives that have happened since you started watching. So, sorry. So, if we work this problem out, so I need to set 20 equal to 100 times a half to the t. Then when I divide the 100 over, I'm going to get 1/5 on this side equals 1/2 to the t. And so then I can take the log of both sides, or you can do the conversion formula, whichever way you like. I'm going to use the conversion formula. First, yeah, I'll just do it this way. So it'd be log base 1/2 of 1/5 equals t. And then I'll just call up my calculator here, run that. So there's the calculator. So if you go to alpha F2, there's that number 5 is the log base shortcut. So it's log base 1/2, so 0.5 of 1/5. So I can type in 1/5 or 0.2. And so that is about 2.322. But remember, that's not hours. That's 16-hour increments. So what I need to do is take 16t, and that'll be 16 times 2.322. And so that's going to be times 16, about 37.2 hours. Did I do that right? Yeah, about 37.2, let's say, roughly. Okay, so that's one way of doing it. Some students don't like taking that t and saying, oh, t is really 16-hour increments. So here's another way you can do it. You can instead set it up like this. F of t equals 100, and then you know that you're cutting it in half every 16 hours. So you got to raise it to some power. And the mistake students make is they say, well, let's put 16t there. But if you think about it, if t is supposed to be, so in this case, we want t just to be regular hours. So if I plugged in 1 right there, then that means that after 1 hour, I've cut the 100 in half 16 times, right? That's not what you want. You want that when you plug in 16, you've only cut it in half once. So instead, you're going to do this, t over 16 right there. That's how you avoid that issue. So if I put t over 16, now I'm cutting it in half once every 16 hours. So then if you solve this directly, so let's see, 20 equals 100, 1/2 t to the 16th. So then if I divide by 20, or divide by 100, I get 1/5 equals 1/2 t to the t over 16. And then if I use my change of base formula, or not change of base, if I just rearrange it in the log form, then I get log base a half of 1/5 equals t over 16. And notice that's the same thing as this. And then I'm going to multiply by 16. So that's what I'm doing right here. 16 log base 1/2 of 1 over 5. And if you plug that into your calculator, you're going to get 37.2 hours. Okay. By the way, this right here, you could also end up rearranging this as 1/2 to the 1/16 all to the t, just to review a little bit of the, what's it called? The exponent rules, exponent rule, whatever. You got it. Okay, I'll talk to you.